It's time for absolute basics. Here is a cell. The fluid inside a cell is called intracellular fluid. The fluid outside a cell is called extracellular fluid. This would include blood and tissue fluid. The word intra means within. Extra means outside. There is always more potassium inside a cell compared to the outside. There is always more sodium outside the cell. So there's more sodium in the ECF. There is more calcium outside the cells. If a calcium channel opens, there will be movement of calcium down the gradient into the cell. So there will be a calcium inflow. If sodium channels open, there will be a sodium inflow down its gradient. If potassium channels open, there is outflow of potassium down its gradient. This type of movement down the gradient through a channel is called facilitated diffusion. Let's review an action potential in a neuron. We have minus 70 millivolts, minus 55 millivolts, 0 millivolts, and plus 20 millivolts on the y-axis. Minus 55 millivolts is what we call the threshold voltage, the minimum voltage needed to start an action potential. Minus 70 millivolts is the resting membrane potential when the neuron is at rest. Then there is a slight depolarization, hits minus 55, and there is a rapid depolarization going up. There is a repolarization going down. There is further down, which is the hyperpolarization, and going back to resting membrane potential. The going up of the action potential is called depolarization, which means voltage going towards zero. Number 2 is repolarization, which is voltage moving away from zero. 3 is the hyperpolarization is so low that it is below the resting membrane potential. So here we have it. Number 1 is depolarization, is rising, and it is moving towards zero. Repolarization, falling and moving away from zero. Hyperpolarization, so low that it is below the resting membrane potential. And minus 55 is the threshold voltage, minimum voltage needed to trigger an action potential.